Hi guys, I hope you are fine. Me too, I'm fine. So we are going to do these problems and we are going to use what we call integrating factor. But before we do them, let's remind ourselves of what is integrating factor. So guys, let me just divide it here and show you. So if you have an equation like this guys, that is dy all over dx plus p y equals to q, like that. For this equation we use what we call integrating factor. The integrating factor is given by integrating factor is equals to e raised to p dx. So this is what we shall be using for these two equations. So when we find the integrating factor, we multiply all the values here, that this one, and that one, so that we make this now to become exact equation. So this is what we now do, guys. We come for the Roman one. We are going to arrange it in this format. So this one is going to be x dy all over dx plus 2y is equals to 3x. So guys, we come and divide. For us, for this equation to be like this, we divide by x, all the sides. So we shall have now, if we divide by x, we shall have now dy all over dx plus 2 over x. Here we have y, and this one now is going to be 3. That's when we divide that, the whole of that equation, we divide by 1 over x, like that. And the reason we do that is so that we can leave the whole equation in this format. Now we come and employ the integrating factor. So the integrating factor is going to be now equal to e raised to now the number that is here now, which is 2 over x dx, like that, guys. So now when we come and solve this one, we are going to get something like this. Integrating factor will now be equal to e. You integrate this one, you will have ln, like that, x squared. So this one becomes now, when you do it, it will be x squared. So guys, our integrating factor is x squared. We now come and multiply all of this with x squared. So we shall have x squared dy all over dx plus, we multiply here by x squared, you'll have 2xy is equals now to 3x squared. Now this equation now become exact, so that now we shall put our left side now will be d all over dx integrating factor, like that, multiplied by y. This now will give us the differential equation on this side. and this one will be equal now to 3x squared, like that. So that now, guys, we can come and integrate both sides. We integrate this side and we integrate this side. So guys, we are going to have integrating factor, which is x squared multiplied by y, like that. This one now is going to be equal to 3x cubed. Now this is cubed all over 3 plus now constant. So finally, guys, we are going to have this x squared y is equal now to x cubed plus c. So this is our answer, guys. So guys, that question is done in that format. Guys, we now come to this other question. Let me write it down. That is dy all over dx plus 1 minus x, that is y, is now equal to 0. For this one now, guys, our integrating factor, since it's already written in the format that we want, the integrating factor is going to be equal to e integral 1 minus x dx, like that. So this one is going to be e, it's going to be e, then we have integral of 1 is x minus now x squared all over 2. So guys, that is going to be our integrating factor. So we come here and multiply every side with that one. So we start here, we say e raised to x minus x squared all over 2 multiplied by dy dx, that is now then plus, you multiply here, that is e raised to x minus x squared all over 2, then 1 minus x, like that, and then you have y. This is going to be equal now to 0, because when you multiply anything with 0, it will remain 0. So on our left side, we are going to have this d all over dx, because now it has become an exact equation. We put now integrating factor, which is e raised to x minus x squared all over 2. Then we put our y, like that. So this one is the one that will give us 0, like that, guys. So from there, guys, we integrate both sides. We integrate this side and also we integrate this side. So this side we shall have e raised to x minus x squared over 2 y, like that. This one will give us This one will be 0 plus a constant. So there is going to be a constant there. So guys, if we leave y on one side, we shall have y will now be equal to the constant all over e raised to x, like that. And we can also put it another e like that, which is similar to whatever we have here, negative x squared over 2. So this one, guys, is from the EDCs. So this is what now we are going to have as our answer, guys. So, and that's how we do that question, guys. And so, guys, thank you for listening to me. So that's how that problem should be done, together with the first that we had done already. So guys, thank you for giving me your ears. I so appreciate so much. So guys, the next we shall do now differential equation, or I could say second order differential equation. So guys, thank you so much. Bye bye.